All right, you magnificent bastards, buckle up for a deep dive into a shit ton of space rocks.
Space rock!
Yeah, asteroids. Those fuckers that can make us rich or wipe us out. We're going to unpack all that today.
Sounds intense.
It is. We're using Wikipedia for this one. And to guide us through this cosmic minefield, we've got asteroid aficionado expert speaker. Welcome to the show.
Glad to be here.
Let's cut the crap. What gets you so excited about asteroids? Is it the whole space mining angle or the we're all gonna die thing?
You know, for me, it's that asteroids are like time capsules from the birth of the solar system.
Well, like they've been hanging out since the beginning.
Exactly. Leftovers from the party that made the planets, just floating around, waiting for us to figure them out. And yeah, the whole extinction thing does make them a bit more interesting.
Okay, true. Okay, so basics first. What the hell is an asteroid? I mean, is it just a sad planet or a comet with a bad hangover?
Think of it as a wannabe planet. Too small to be a planet, but bigger than a meteoroid. Just rock or metal or ice, hanging out, orbiting the sun. The big difference between an asteroid and a comet is comets have that coma, the visible cloud and tail, caused by ice and dust heating up when it gets close to the sun.
So like a comet's flashy and an asteroid's just kind of there.
Basically.
Gotcha. But isn't calling them vermin of the skies kind of harsh? Even for space rocks.
Yeah, it is a bit of an old-fashioned term from when we were finding a ton of them and didn't know what to make of them.
True, there are millions of them, so I guess it did kind of look like an infestation. Okay, so how did we even find these sneaky bastards? Did some astronomer like bump into one on the way to the space bathroom?
It's pretty wild how long it took us to figure out asteroids even were. Astronomers saw them, but they thought they were stars or comets for centuries.
Centuries?
Yeah, until like 1801, when Giuseppe Piazzi was mapping the sky and he saw something that wasn't supposed to be there, moving around.
And what was it?
The largest asteroid in our solar system series. It's so big we call it a dwarf planet now.
So we were clueless about these giant space rocks for like hundreds of years.
Yeah.
It's kind of embarrassing.
Well, technology was limited back then. Finding an asteroid was like trying to find a needle in a haystack. In space.
Seems complicated.
It was. Photograph the sky, compare images to see what moved, then calculate its orbit. Lots of math.
Oof. Sounds like a pain in the ass.
Right.
Finding one asteroid is rough, but there's like a whole belt of them. It's like Star Wars, with spaceships dodging rocks left and right.
Not really. The asteroid belt is massive, like a giant cosmic junkyard, orbiting the sun between Mars and Jupiter.
So it's huge.
Absolutely. But the distances between these rocks is vast, millions of them, but the chances of hitting one are tiny, more like driving through the desert. See a cool rock once in a while.
So it's more like a boring road trip than an epic space battle.
Pretty much.
Bummer. You mentioned big asteroids, the VIPs of the junkyard.
Yeah, you've got Ceres and Vesta and Pallas and Hygeia.
Those are the biggest.
Yep. The belt's total mass is actually low, but those guys make up a good chunk of it. Ceres is the biggest, about the size of Texas.
Hold up. Texas-sized space rocks? Now, those are some bad boys I wouldn't want to mess with. Are they just boring lumps of rock, though?
Yeah.
Or do they have personalities?
They each have their own thing going on. Ceres is round.
Round. Like a planet.
It's got enough gravity to pull itself into a sphere. That's why it's a dwarf planet. It might even have an ice layer.
Ice. Like water ice.
Yeah, under the surface. Which is pretty crazy for an asteroid. Then there's Vesta, mostly rock, volcanic rock. It's got layers like a planet. And some meteorites we find on Earth, scientists think they came from Vesta.
Whoa, so Ceres is like the icy queen and Vesta's the volcanic rock star. What about the other two? Pallas and Hygeia? That's interesting.
Totally. Pallas is kind of the rebel, spinning on its side like it's flipping off the rest of the solar system. Similar to Ceres in what it's made of. Carbon and silicon. Might even have layers like Vesta. And Hygeia is the largest carbon asteroid we know of. Could be a survivor. Smashed to bits in the past, but pulled itself back together.
A survivor? How the hell does that even work?
Gravity's a hell of a force.
True that. So we've got an icy queen, a volcanic rock star, a rebel, and a survivor. Sounds like the asteroid belt's more like a cosmic soap opera than a boring road trip.
Mm.
But are they all made of the same stuff? Like if we ever want to mine them, do we know what we're getting?
That's where it gets tricky. We classify them based on their orbits and how they reflect light.
Reflection, like a mirror.
Kind of. It tells us what they're made of. Most common types are C-type, S-type, and M-type. C-type are full of carbon, S-type are rocky, and M-type are metallic.
And which one's best for mining?
M-type's probably got the most valuable stuff, but even within these types there's huge variation, like saying all humans are the same. technically true, but there's a lot of diversity.
So you could go mining for platinum and end up with space dirt. That's gotta suck. But we've been talking about these asteroids like they're just rocks. But they could hold clues about where life came from, or they could slam into Earth and wipe us out.
You're not wrong. Asteroids aren't just useless rocks floating around. They've got secrets about where we came from, and maybe about how we'll all go out.
Okay, drama queen. So you're saying those classifications aren't always right? Can they, like, trick us? Those spectral things?
Sometimes the light reflection makes it look like one type. Then we get closer and it's something totally different.
So they're messing with our scientists.
Kinda like a cosmic catfish. It keeps things interesting. One of the biggest surprises is active asteroids.
Active asteroids? What the fuck are those?
So you've got your typical asteroid just hanging out in the belt. Then suddenly it starts acting like a comet.
Wait, what?
It sprouts tails, starts shedding material, like a cosmic meltdown.
What the hell causes that?
It's like they're showing us what they're really made of. One example is 7968 Elsp Pizarro, found in 79, thought it was a regular asteroid. Then in 96, they noticed it had a tail. Turned out it was ejecting dust, probably spinning too fast.
So like a cosmic wardrobe malfunction. But what about the water and organic molecules on asteroids? Is that for real?
Oh yeah, it's legit. In 2009, scientists found water ice on 24 Themis, an asteroid in the main belt. They think it might get refilled from underneath the surface.
So these space rocks are giant water bottles.
In a way. And they found organic compounds too, like amino acids, even sugars.
Sugars.
Okay,
Like the stuff in my coffee. What the hell?
I know, right? And that discovery supports the idea of panspermia, the theory that life on Earth came from organic molecules, brought here by asteroids or comets.
So we're all just a bunch of alien hitchhikers.
Maybe. So instead of boring rocks, asteroids might be the reason we even exist. But how do we even study these things up close? Do we just send astronauts up there with a pickaxe?
That'd be pretty badass.
Maybe someday. For now, we use robots, space probes. They travel to asteroids, orbit them, take pictures, collect data, even bring back samples.
Like little robot spies.
Exactly. One of the first was in 91, Galileo probe. On its way to Jupiter, it passed 951 Gaspra, took the first close-up pics of an asteroid. Then in 93, it saw 243 Ida, found out it had a moon, Dactyl, the first confirmed asteroid moon.
Pretty cool. So Galileo was the first to get up close and personal. What about missions that actually focused on asteroids?
Oh yeah, there have been some amazing ones. In 96, NASA launched near Shoemaker, the first spacecraft to orbit an asteroid, 433 Eros. It even landed on Eros in 2001, sent back all this info about Eros, what it was made of and stuff.
Landing on an asteroid, that's some serious sci-fi shit.
Then in 2003, Japan launched Hayabusa.
Japan's been in the space game for a while.
Oh yeah. Hayabusa was the first mission to bring back samples from an asteroid. Landed on 25143 Itokawa, a tiny near-Earth asteroid. Got samples and brought them back to Earth in 2010.
Samples. Like asteroid souvenirs, what did they find? Alien DNA.
Not quite. The samples showed it was a rubble pile asteroid. Been through a lot of impacts over time.
So even tiny asteroids have been through some shit.
Pretty much. But what about those big ones, like Vesta and Ceres? Have we sent probes to them?
Yeah, good question.
Totally. NASA launched the Dawn spacecraft in 2007. It orbited Vesta for a year, sent back amazing pictures and data, showed all these crazy surface features in its history. Then in 2015, Dawn went to Ceres, first spacecraft to orbit a dwarf planet. Spent years studying Ceres, confirmed there was water ice, and found those bright spots everyone was talking about.
Bright spots. What are those? Like it was trying to signal us.
Scientists think they're made of salts, really reflective, left behind after salty water came up from inside Ceres.
So Ceres was having a spa day.
Pretty much. It's amazing to think how much is happening on these asteroids, and we can't forget about Hayabusa 2.
Hayabusa 2, like a sequel?
Yep. Japan's follow-up mission, launched in 2014, got to its target, 162173 Ryugu in 2018. This mission was even more ambitious, touched down multiple times, took samples from the surface and below, even deployed a small lander and some rovers.
Rovers on an asteroid. Are there like asteroid parking tickets?
Not that we know of, but the rovers took pics and data about Ryugu's surface. The samples got back to Earth in 2020. Scientists are still checking them out, trying to learn about the early solar system and how life started.
So we've got probes orbiting, landing, collecting samples, deploying rovers. It's a full-blown cosmic takeover. But let's be honest, it's not all about science. There's the whole asteroid mining thing. Is that just a fantasy, or could it actually happen?
It's not as crazy as it sounds.
No.
Asteroids have valuable resources: platinum, gold, Rare metals that are hard to find on Earth. If we could mine them, it would be a game changer.
So we're talking space riches. I'm in.
Pump the brakes. It's still early days, lots of challenges. The tech is hard, and we don't even know if it's worth it economically.
Okay, so it's a gamble,
Yeah.
but a big one. But what about the ethics and environmental stuff? Are we just going to rip apart these asteroids without thinking about the consequences?
That's a huge debate right now. Some people say we need rules before it gets out of control. Others think the benefits are worth it, that we need this for the future.
Tough call. Greed versus responsibility.
Mm-hmm.
But on a cosmic scale. But let's face it, as cool as space mining is, there's a scarier question. What about the asteroids that aren't just chilling in the belt? The ones that might come and crash our party, you know, the planet killer kind?
That's the big one. The threat of an impact. We have to take it seriously. Remember the dinosaurs?
Yeah, those poor bastards. Got a wake-up call they weren't expecting. We don't want to go out like that.
Yeah.
Because some asteroid decided to drop by.
We're not totally helpless, though. Scientists are keeping track of near-Earth asteroids, the ones that come close to our planet. They use telescopes and radar and stuff to see where they're going and if there's any risk of them hitting us.
So like a cosmic neighborhood watch. For shady space rocks.
Exactly. But let's say we do see one headed right for us. What's the plan? Nuke 'em. Like in the movie.
That's what I do.
Nuking is one option, but not the only one. Might not even be the best. There's kinetic impactors. Basically, you ram a spacecraft into the asteroid to change its path. Or gravity tractors. Spacecraft that use their own gravity to pull the asteroid away.
So we're talking cosmic billiards and messing with gravity.
Yeah. Pretty advanced stuff.
Sounds cool. But how good are we at actually predicting these impacts? What if we miss one? Talk about a bad day.
That's the tough part. It's a complicated field, and we're always learning, we're getting better, but there's always that risk. Space is huge, and those asteroids can be hard to see.
Okay, that's kind of reassuring. But even if we avoid a giant asteroid hitting us, they're still out there. What if one of those active asteroids spits out a bunch of debris towards us?
That could definitely happen. Another reason to study active asteroids, we need to know how they work. What makes them do that if we want to be ready for anything?
Ready for anything? Like what? Give me the worst case scenario.
Well, a big dust cloud from an active asteroid could mess with satellites, cause problems in the atmosphere, maybe even change the climate.
Okay, now I'm officially freaked out.
But hey, that's the excitement of exploring space, right? Pushing the limits of what we know and facing the unknown.
True. But I might be sleeping with the lights on tonight.
Mm-hmm.
What's next for asteroid exploration? What are they working on now?
There's some really cool stuff coming up, like NASA's Psyche mission launched last month, going to 16 Psyche.
Psyche.
Yeah, it's a huge metal asteroid. Scientists think it might be the core of a planet from way back.
So we're going to see the inside of a planet. Sick. Why is that so important, though? A metal asteroid.
It could tell us how planets form, how they end up with layers, the core, the mantle, the crust. It's like a time machine back to when planets were just starting to form.
So it's like a cosmic history lesson.
Yeah.
Awesome. Okay, back to asteroid mining for a minute. Still want to get rich in space. Are we any closer?
It's still a long way off. The tech is hard. And it's expensive. But the payoff could be huge. So companies and governments are putting money into it. It's like a gold rush in space.
The possibilities are insane. Imagine the stuff we could get from asteroids. It could change the world.
We have to be careful, though. We can't just take whatever we want from asteroids without thinking about what it'll do. We need rules, sustainable practices. Otherwise, we'll just mess things up even more.
True. It's a balancing act. The benefits versus the risks. Okay, expert speaker, wrap it up for us. What's the big takeaway about asteroids?
The big thing is asteroids are way more than just rocks. They're leftovers from the early days of our solar system. They might tell us how life started, and they could be important to our future. Whether it's mining them, stopping them from hitting us, or just figuring out our place in the universe, they're a big part of our story.
Damn, that was deep. All right, that's it for today. Thanks to Expert Speaker for all that awesome info. And to you, our listeners, thanks for tuning in to The Deep Dive. Keep looking up at the sky. Space is pretty damn cool. Peace out, bitches.